Good morning, hello, happy Sunday. We are going to be continuing our deep dive into Rust, and as luck would have it, Rust did an update. So we need to also take care of that ourselves. So Rust update. This will bring us up to 1.5.5.
Hi, Sophie. Okay.
And let's see, we need to go take a look at the release notes for that. Because while we're sort of like diving into Rust, the standard library, things are changing, and things may be changing across what we've already looked at. So if we remember, we've been going into arrays, and then sort of like the debug, format debug, and then standard format. In arrays, let's see. Basically, we're at this point right here where we're just sort of going into all the different traits that you can run on arrays that, that everything inside of it can also run. And so we're currently on debug. However, here, let's see what updated, if anything updated in like what we're checking out so far. So cargo deduplicates compiler errors. It's not something we need to worry about for our deep dive. But I think now it's basically not going to show the same error twice. Oh, it also prints a report at the end of compilation, which might be easier to see, potentially. Let's see, faster, more correct float parsing. Faster will be nice, although I don't do too many float parsings, but perhaps now I could. So previously I was doing like because I'm doing GGEZ a lot, and GGEZ internally just sort of requires F32s. I just use F32s everywhere. It never needed to do any kind of parsing. So that maybe we can try some like F30, F64s. Is there F16s? I think there is. If we need to. Let's see. Error kind variants updated. So we have not dove into error kind yet, so we don't need to worry about that. Just to double check, we should have an error kind in here. So I think this is standard error kind variants. That sounds like an enum. Although I also don't find it here. Oh, no, here it is. Error kind, IO error kind. There it is. So yeah, we haven't looked into this yet. It's an empty page. Open range patterns added. Okay, so we stabilized open range patterns. Oh, so we can now match with like 1 ... So 1 through 32. Oh, it is nice. There's been several times where I'm like, well, I wish that I could do ranges or that kind of thing in a match statement before. And now we get it. Okay, the APIs that were stabilized. So bound cloned, I don't think we're bound, we haven't looked at. Drain, we haven't looked at. Into inner error, we haven't looked at. Maybe unit it. That seems interesting too. It's a very interesting word. But look at this, array map. And then everything else we haven't looked at whatsoever. But array map has updated. So if we come over to array again, Darth Millennial, hello. My weekend is going pretty well so far. How about yours? How's yours going? So we're gonna come down to methods. So implementations, and here's map, and it is no longer nightly only. So that's actually a pretty big deal for us. Let's head back into arrays. So this now comes up here. It's good. You got tea and biscuits. Life is good. Yeah, I've got my own morning tea. I don't have any biscuits. I haven't been doing like the breakfast thing recently. I've been sort of like just skipping and going to lunch. And I've been trying not to eat too many carbs, but besides that, I am totally there. I can't wait until I can though again. Okay. So map is an actual thing, although we're not there yet, because we're still going through these. It just is interesting that something that we already started going into has been updated, which is really nice. So it looks like to us though, we are going to stay in the standard format. Module standard format. Which I think was through debug. Yeah, arrays debug format. So debug. And then somewhere in here is format. Oh, could it be this? Let's go into debug and see what we left off there. Oh, module standard format. When possible, just derive the debug instead of manually implementing it. So then we have this module standard format. So yeah, I don't think it got there. Use standard format. We're sort of like continuing looking at arrays, but we're in the traits that you can run on arrays if things inside of it have it. So we're going to continue looking at like whatever this is. So I think inside of debug, there's this format. And I think there's the two ways, because like we can, for this trait, there's the derive macro that we can use, or we could manually implement it ourselves, which I think is something like this. Rodolfo Silva, hello, good morning. And then there's this entire formatter. Is that a macro? Doesn't look like it. Is it a struct? Maybe? But basically, okay, so this goes into standard format. So inside of here. Not necessarily seeing a link to standard format from here. I guess it's just implementing debug for that format debug. Oh, this is how we manually implement it. Oh, right. So we go back. So we can derive it instead of manually implementing it. So using standard format for manual implementation. You're working on a web app in Rust with Tide. You think it's a good library? Nice. I don't think I've looked at Tide, although I've heard it from you and I think maybe someone else too. I mean, it sounds pretty good. Although there's the new, what is tied? Is tied? Remind me what it is. Is it the backend? I think it's the backend framework part, right? So, and basically here in standard format, which there's no link here for that. So we're gonna search for, oh, we can just, utilities for formatting and printing strings. That's what this is. This contains the runtime support for the format syntax extensions. This macro is implemented in the compiler to emit calls to this module in order to format arguments at runtime into strings. Okay, so it's a backend server like Express in JavaScript, and it's quite modular. Oh, nice. Yeah, I think. Yeah, okay, so if we're gonna use it for manual, so it wants us to derive debug. I think that in here. Generally speaking, you should just derive debug. Oh, this is what that is. The module level documentation. For more information on formatters, that's where we came to this. So this is the module for this. I don't think we have, I must have added like a standard format module in Notion for this somewhere. But okay, so it's an entire module. It holds all of these different things. Contains the runtime support for format syntax. So are you in traits? I don't think you should be in traits. You should be in modules. You're not. Okay. I actually don't see where this came from. We should add a module section. And then in here, we can do the module format. Module standard format. There it is. Okay. So, okay. So utility supporting the format macro. This macro is implemented in the compiler to emit calls to this module in order to format arguments at runtime into strings. So I think this is like one of my favorite tricks is like the format macro. So, which is actually part of that. We'll get into that a little bit. The format macro is intended, so then I guess we can go into that. So format macro can create strings using the print line syntax. And I guess it's the print line macro syntax. At runtime. It's pretty cool. So you can take like a number, you can take anything else. It's sort of like using toString, but you can also like build new strings from it at any moment in time. So the way you can use it is you can say like let my string equals and I guess like let's do like hello. Is that we would have like maybe our name is equal to, we can have this be like something like a static string. So let's just say like, I don't know, Jane. And then we have like, I don't know, maybe some like other like health. Let's do that. Health. Stay in like sort of the game world. Jane's health is 100, and so then we can create like this hello string that's like printed out. Maybe it's a status string, and this could be then the format. And it's exactly the same as print line here. We're gonna have sort of like name that health that exactly like that, and then that's a full string now. So this is exactly that for us. Additional parameters passed to format. Okay, replace the little handlebars or mustaches or whatever we want to call them. To convert a single value to a string, use the toString method. This will use the display formatting trait. Yeah, so we could just do toString on something, but we don't need to. Like that's just saying like, hey, instead of format, we could just do toString. This will panic if a formatting trait implementation returns an error. This indicates an incorrect implementation since format right for string. Oh, okay. So basically, if there's an error, like something doesn't implement display, that could be a problem. And I believe we can still do like the colon question mark too, if we want to. So this panics if cannot format. Object cannot be formatted. Right. So like right for string cannot implement error. So like there's never going to be an error that gets returned. And then there's those examples. Okay, so that's good for that. Then we're back into standard format. The format macro is intended to be familiar to those coming from the printf, fprintf functions. If you're familiar with C, and it does like feel a lot like that. And then it looks like we have a bunch of these things that we can do here. So that obviously just like puts in what we're used to, but then there is this like debug. So display formats. How do I want to do this? So obviously just like display the thing. Then there is display the debug thing. You could have named ones. Okay, so we can name this. So display the named value. As in, and then I think I should give that an entire example. So display the named value, example, that. Okay, so display two things, that's fine. Okay, this one is leading zeros. So display, is it, oh, okay, so display up to 4 leading zeros. So, and then the example would be something like that. And then this, oh, is the pretty print. This is the pretty debug print. So, pretty debug print. Each formatting argument is allowed to specify which value argument it's referencing, and if omitted, it is assumed to be the next argument. For example, the format string sort of bracket would take 3 parameters, and they would be formatted in the same order as they're given. The format string 210, however, would format arguments in reverse order, because then we can just see it. And so it starts with 0, I guess. Things can get a little tricky once you start intermingling the two types of positional specifiers. The next argument specifier can be thought of as an iterator over the argument. Each time a next argument specifier is seen, the iterator advances. This leads to behavior like this. So yeah, we can see like, okay, give me 0, 1, so give me 2, and then I guess it's the first one, and then give me the first one, and then give me the second one. Oh, that's interesting. What library do I use for my preferred backend server? I don't know. I go back and forth between a lot of different things. For APIs recently, if it's Rust, I want to explore Rocket a little bit more. I've used ActixWeb before and I really liked it. Let's see. For just like normal use cases, I think Express and JavaScript is excellent. And then sometimes just Lambda functions. If things are simple enough, then I don't need to have a true backend. Format string, okay, so that's interesting. This is super interesting that we can do that. Named parameters. Rust itself does not have a Python-like equivalent of named parameters to a function, but the format macro is a syntax extension that allows it to leverage named parameters. Named parameters are listed at the end of the argument list and have the syntax. Okay, so this like identifier equals expression. For example, the following format expression all use named argument. Oh yeah, okay, because we have this thing like argument equals test, for example, here. And this one is like name equals 2, which that brings 2, and then Oh, because this one, I missed that one. So 1. So that's certainly possible to do. It's not valid to put positional parameters, those without names, after arguments that have names. Like with positional parameters, it is not valid to provide named parameters that are unused by the formatting string. Each argument being formatted can be transformed by a number of formatting parameters corresponding to format spec in the syntax. These parameters affect the string representation of what's being formatted. So all of these print hello X. So 5 spaces after the X. Oh, interesting. Look at that. So we have then 5 after that. I kind of want to play with this. So we have Rust Analyzer, so that should just sort of like help us out with this. We should be able to see each of these. Now, I'm mostly interested in like converting these print lines into formats and then setting something up at the beginning, like let string 1. Oh, didn't mean to do that. String 1 equals to that. You'll be 2, 3, 4. Are you going to show me? Oh, you just show me the type. You don't show me what it actually is, which would be really nice. Okay, fine. We'll go back to print lines then. Because then we'll actually see it printed out here. So we'll see here all of these spaces like that. So this one gives us spaces after this X. That's my guess. So if I have something like 9, we get 9 spaces after the X. Now I don't think we can do something like 5 in front of it, right? Like 5 spaces in front of it. Yeah, no, that doesn't like that at all. Because I think that would be position 5 in here, which doesn't exist, and then 9 spaces after that. If I do like 0, 9. Oh, I think that needs to be like a number for it to give the leading zeros. Because if you're not an X, but you're like a 5, then we see leading zeros like that. And if I remove the 0, it's just the spaces in front of it. So that's actually really interesting. Like it depends upon what you're getting with this. So let's see. Other fun little things here. So this is display up to 4 leading zeros. And then another one would be like 4. Display 4 leading spaces. For a number. But then if it's, and then I guess it would be like, or, 4 spaces after a non-number. Okay, so then you are, this is the number of spaces for that. So that's, yeah, so in you, we're gonna do like 9. So wait, I'm okay. Let's put these all back to where we found them. So you're 5. So then yeah, that's 9 spaces here. Now this $sign is, I guess, taking Oh, wait, no. So the $1 $sign. Oh, that's taking U as the value here. But because it's colon, it's taking this as that. Okay, got it. Because I could do something like this, and then it's still taking X. And it's exactly the same there. Which means that I could create this in a loop and have this number be basically dynamic at this point in time. I think that's what it's trying to say is I can now do that dynamically. So if we wanted to do something like for we'll do like spaces in, yeah, sure, 0 through 10. Then I want to do, look at that. Okay, so based upon what we have up here, this is what Copilot thinks that we want to do. We can have this like width, dollar, width equals spaces. That's kind of correct. We can also do this with the named thing here too, apparently. But I don't need to do that. I could also just do $1 and just have U like that. And that is also valid. So if I run this, wait, why are you upset? Why are you not upset here? And why are you upset here? Expected. Oh, it's the opposite. Dollar in that direction. Oh, and you need to be colon 5. That puts you afterwards. Huh. I thought that was gonna make it go up and like spaces after it, but it did not. We have to, okay, do I have to do the 0 in front of it to make it show? No, it doesn't like that at all. Oh, wait, no, because I, oh, it's not that. Oh, because that's the 5-0. So it needs to be 1 to see spaces here. And it's the $sign to like take this value in and bring it in there. And we're seeing the X. So we're seeing this X be printed out here. It's just on the far left, and we're not seeing the number of spaces increase like this. Do you have to be non U32s for some, or I32s? You should be, because these are I32s. Now we could just do this width one here. So we can try that again. So we can do width equals, but I don't see how this is going to change really, because it's going to be the same thing where it's width that. Yeah, and like there's no extra spaces in there. And if I pull you back in, we have these. Oh, is it because we don't have anything at the end here and we need to show that? Oh, I think that's what it is. We need that. There it goes. Now we see the extra spaces being added in here like this. So if we did this as actual just numbers, then we're not gonna have this. Okay, so we're gonna have spaces here like that as our then I'm gonna do 0 $sign for this. Oh, because I want it to be something like the 05. Don't know if that's gonna work. Yeah, it doesn't. Argument is never used. It's trying to use this one again for that. Oh, do I have to backslash it? No, it does not like that at all. So that gives this up, and we see the leading zeros here. Can I see, like, how do I make it like actually do the leading zeros? There, double zeros. Double zeros would do. So position 0. So I think this one is the position 0, and then I want leading zeros in front of it. So if you ever need to do one of those like silly computer science algorithms where you like print out a diamond, this is a way to do it. Okay, so I think that's a good one if we want to let's see, what is this? This is basically expand a variable, use it in the I guess like statement, then we need an extra 0. Example, this entire thing. And that outputs that. Okay, that's good. This is a parameter for the minimum width that the format should take up. Right. So that's like the minimum width. If the value string does not fill up this many characters, then a padding specified by fill alignment will be used to take up the required space. The value for the width can also be provided as a usize in the list of parameters by adding a postfix $sign indicating that the second argument is a usize specifying the width. Interesting. Isn't that what we were doing? Referring to an argument with a syntax does not affect the next argument counter, so it's usually a good idea to refer to arguments by position or use named arguments. Okay, so best practice. So when using like $sign is to use positional arguments or named arguments. And you're doing that because it does not, okay. Doesn't affect the next argument sort of counter, which could be a bit confusing. Okay, fill alignment. The optional fill character and alignment is provided normally in conjunction with the width parameter. It must be defined before width, right after the colon. This indicates that the value being formatted is smaller than width. For some extra characters will be printed around it. Oh, so we can put whatever we want. Oh, substitute doesn't. Hey, fix that, please. Thank you. Thank you, KO2 fan. So we can put in whatever we want at this point in time, I think. Is what they're saying. So we can do that. Oh, that gives us that. That's not easy. Okay, there we go. That gives us that. So let's say we don't want zeros. Let's say we want these dashes. That doesn't work. So we're getting 0 for that position. That to expand it out. That's interesting. So does that only work with strings? Like if I do this as like a 2 string. Oh, now it's space like that. Oh, expected a U size. Oh, because this needs to be a U size. Oh, so we need to convert that into a U size. That's it. So dot into for that. But then that means we need like a spaces here for this one. So then you become something like that. Into, okay, so like as a U size. That still doesn't give us that. We still see these spaces come in here that way. Do we need to do something like, can't imagine. So what character, how can I get that to like actually display it? Oh, you don't like that at all. Oh, there's no argument named _1. Oh, because that's a named argument. So really we should do width equals to that. So then we just do width. Now how do I tell it this thing to do? That I want this to be the character to display. I have to use this less than sign. Oh, look at this. Okay, fulfill less than. The argument is left aligned with the width. Oh, okay, so I need the argument is left aligned, center aligned. Oh, that's nice. Okay. So I do need to do this thing and I'm missing that. And now we see that. So that's left aligned. I can also do right aligned. And then center aligned should be that. Just a little bit odd, sort of like seeing that. But if I want to like make any kind of, I don't know, like terminal output and not use like one of the big libraries for like displaying to the terminal, this could come in handy. Now, can I do something like I want 5 of these? 1, 2, 3, 4, 5. No, oh, okay. So I'm doing the numbers like that. So I didn't want this thing width equals, let's just say that I want you to be An odd number would be best for this, so like 9. And now they're exactly in the middle like that. So, setting the prefix, is that what I called it? The fill character. So, setting the fill character needs a sort of like a directional character, a keyword, a symbol, maybe. Of, and this is less than or which means sort of like start to the left of. So format left, justify left, justify left, justify right, or justify center. The default fill argument for non-numerics is a space and left aligned. The default for numeric formatters is also a space character, but with the right alignment. If the 0 flag is specified for numerics, then the implicit fill character is 0. So can I set a fill character to be a number, even though that doesn't make any sense? Like, can I do that? So can I say something like, I want you to be not dashes, but like, I don't know, 5 for some reason. I can. So I can totally set it to be any arbitrary character I want whatsoever, which means, what's the key? Oh, there's like a key. No, that's not it. I forget the keyboard thing to like get the, little Unicode representations. Yeah, let me see if I can copy out of here. So we're gonna do a do that one. Can I copy you and put you in there? No. Oh, it's an image. That's the problem. It's an image. That's not Unicode, I guess. I guess that makes sense. That's not standard Unicode. I need to go find some Unicode stuff. Code. Just like a list of them. Here, we'll choose this explodey one. So I want to do U plus 1F4A5. Why can't I save you? Okay, so U plus 1F4A5. So U plus 1F4A5. Can I do that? Is it lowercase u? Invalid format string. Okay, that's not happy. Right. No, it's uppercase. 1F4A5. I wish I could copy that, but it's an image. Oh, can I set this to be a character? Can I do something like let filler equals, we're going to do a character like that. So we're going to do U plus So it's like 1F 4A9, so 4A5, that. You don't like that. Okay, so it can't create a character Unicode for that one. Yeah, okay, that's... No, don't want to do that. Fine. You're not... Not what I need. I need like a smaller Unicode then? Is there like a list of them here? Code planes and blocks. Okay, so plane 1. So here's the... Oh, there's like... Oh, arrows, geometric symbols. Here, let's go into the geometric shapes. We'll do this triangle. So this is what you are. Let's try that one. No, not happy. Still only one. Okay, only one code point. How about you? Still multiple code points. Guess I need like way simpler. How about something like this? Just no, it doesn't like that either. Basic code point. I want like the smallest one here. Oh, the U plus 25AA. But I don't think it likes that at all. So, oh, it's too bad. And I don't think I can copy these because I think these are images. I can't, oh, I can copy you, can I? Okay, that might work. There we go. So there is that. So I can just actually just take you in here, but we can just use you as filler, as the name. Oh, this would be 0. This would be filler, like that, which means we need a filler equals filler, like that. Oh, positional arguments. Okay, I don't need... Oh, yeah, so filler. So what, this is 0 for that, and then that's 0. Where are you going? This is 1, like that. Argument never used. Oh. I guess I'll just throw you in there directly. I don't need to use this. Argument never used, then you're back to just that. Okay, let's try. Darth Millennial, thank you for stopping by and saying hi. And there we go. Now we can use that character. So like Unicode characters, as long as it's only a single code point, we can use them for all sorts of interesting little shenanigans with printline and formatting. Okay, so back to you. So we have signs that we can do here too. This is intended for numeric types and indicates that the sign should always be printed. Positive signs are never printed by default, and the negative sign is only printed by default for signed values. This flag indicates that the correct sign, plus or minus, should always be printed. So this plus, okay, so that goes there. Now I'm doing numbers in this one. So like, where would I put it inside of this? Do I put it here after the positional elements? No, not that. How about right before? Maybe. There we go. Okay, so it's plus, and then also I can do minus to show the minus signs, which it shouldn't show at all unless for some reason this is going from like 1 to negative 10. In which case, then it will show oh, I can't go backwards in this, can I? I would have to go something like negative 10 to like 10. Now we see, here's these signs, and then coming along like that. Nice. The hash indicates an alternate form of printing. The alternate forms are, okay, so we can pretty print, so that's the hash question mark. Oh, pretty printed. I don't know if there's a pretty print you can do for numbers. I don't know if that will make any sense. Where does it say it goes? Right after the colon. Or, okay, maybe right after this. Or that. Okay, so that's pretty printing it. It's not really doing anything for us because we just got numbers. If for some reason we wanted to like turn this into a tuple with like, let's just say spaces for some reason. We also have to do like the question mark for debug mode. Not there. Are you there? Then you can see it's pretty printing out like this now. And if I didn't have this hash here, it still works, but it won't be quite as pretty. So that's nice. Let's see. That precede the argument with a 0x. Now that's just precede the argument. That's not actually like making it a different type of number. This is used to indicate for integer formats with padding. Okay. For non-numeric types, this can be considered a maximum width. If the resulting string is longer than this width, then it's truncated down to this many characters, and that truncated value is emitted with a proper fill. Okay. So we can get our precision with like a .n. I don't think we're using numbers like this. I wonder how it works with integers. So is that here? Like .5? Not there. Maybe there. Yeah, it doesn't care about this. But if for some reason I wanted to take these spaces and like maybe this other space, like as an F32. So the second one is going to be an F32. Now we have 5 precision points, and you also notice that the way that this is working is it's only putting one of these blocks on each side. So that's how we can get whatever precision we want, which is really nice. Oh, okay. So in some programming languages, the behavior of string formatting functions depends on the operating system's locale setting. The format functions provided by Rust Standard Library do not have any concept of locale and will produce the same results on all systems regardless of user configuration. That's actually probably something really good to note down. So formatting doesn't sort of like respect the system locale and will display like according to what display. Okay, it will display the same every system in every locale, which is actually really nice in some ways because you're getting exactly what you expect. But if you want sort of like the locale to sort of like come in, which oftentimes like web development, that's what you want, that kind of stuff, you're not going to get it here. The literal characters open and closed curly brackets may be included in the string by preceding them with the same character. For example, the open bracket character is escaped with, okay, open, open, and the closed bracket character is escaped with close, close. Okay, awesome. Syntax. To summarize, here you can find the full grammar of format strings. So all the stuff that we've been sort of like playing with. In the above grammar, text may not contain, okay, yeah, that does make sense. Formatting traits. When requesting that an argument be formatted with a particular type, you are actually requesting that an argument ascribes to a particular trait. This allows multiple actual types to be formatted via like that :x, like I8s as well as I sizes. Okay, so we have like nothing's display, question mark is debug, X question mark is debug with lowercase hexadecimal integers. Really? So wait, is this gonna convert it to uppercase and lowercase? Is that what happens with this? Let's check that out. So if I do a print line, so we're just gonna say hello like this, and I want to do this colon, so colon X question mark. No, that doesn't do anything with like with this. Now, these are integers. So what if I do like 5? Like, what are uppercase, lowercase, uppercase integers? I don't know what that means. Like that's still the same regardless. So I guess I'm a little confused of what these mean. Like, do I actually want to display the hexadecimal integers? Do I have to not use the colon? No, I need the colon. Yeah. Okay, but we can do like octal. Octal hex. So if I don't do the question mark, I'm going to do like 0. That should be the octal for this. Oh, wait. Let's do like 100. There we go. Okay, so here's the octal for 100 in octal is 144. Let's try that like X question mark again. Yeah, here we go. Okay, so this is 64 because it's hexadecimal. So it's 64, and if I do like, I don't know, 1000. E8, 3E8 is 1000 in hex. Now, if I do the lower x, it's going to be, that E is going to be lowercase. That's what it is. I was using too small of a numbers to actually see what was happening. So lower hex, upper hex, pointer. So we can do a pointer to this. I guess I can't get a pointer to like the position in memory for the number. Could I do something with like, let's do like a struct. So like a struct, I don't know, call this like the wrapper. That, yeah, this, all you're gonna have is like maybe like a usize. So then here we can do like let our wrapped number is gonna be equal to wrapper like 10,000. So then in here, I want to do a pointer to wrapped number. Oh, the trait pointer is not implemented for that. Can I do a reference to it? Oh, I can. I bet I could have done a reference to the number. I bet that would have worked. There it is. There's the actual pointer to the position in memory. Now, if I do something like just, I don't know, the like just this number, like that. We also get this. Okay, so I can get like, this is the pointer itself. So, not the contents of it. Binary printing, lower exponential. So I think it's like the E. So what is it, like 1, 2, 3, 4, 5E or E5 or whatever that is. Oh, 1E4. So 1, and then 1, 2, 3, 4. Yeah, okay, so then 4 characters, so 1E4. And then if I do something like, I don't know, dot 55, how do you handle that? Yeah, that doesn't seem. Oh, okay, yeah. 1.00055 E4 to show that you need to multiply it by 4, like, 1 with 4 zeros after it. What this means that any type of arguments would implement the format binary trait can then be formatted with the :B. Implementations are provided for these traits for a number of primitive types by the standard library as well. If no format is specified, then the format trait used is the display result. When implementing a format trait for your own type, you'll have to implement a method of the signature. So like for the formatter. Your type will be passed as self by reference, and then the function should emit output into the f.buffer stream. It is up to each format trait implementation to correctly adhere to the requested formatting parameters. The values of these parameters will be listed in the fields of the formatter struct. In order to help with this, the formatter struct also provides some helper methods. Okay, so we'll probably get to that later. Additionally, the return value of this function is format result, which is a type alias of result. Formatting implementation should ensure that they propagate errors from the formatter. However, they should never return errors spuriously. That is, a formatting implementation must and may only return an error if the passed in formatter returns an error, which makes sense. Like, don't return an error unless it actually is like a real error from the formatter. So here they're creating like a vector. They're implementing display itself for that. And then we're able to use the write macro for this to then return this result into the format. So they're writing into the formatter, which then returns a result. It works out. Yeah, that makes sense. These two formatting traits have distinct purposes. So display and debug. Display is like just the normal display. It is not expected all types to implement that. But here's the interesting thing. Debug implementation should be implemented for all public types. So best practice is to always implement debug. So and that makes a lot of sense, right? Because if you have something and it's like a public library and you're trying to like print it out to like see what's going on, and somebody in the library has not implemented debug for the trait, they're gonna have a really bad day, or you're gonna have a really bad day trying to like see what the heck is going on. And of course, derived debug is usually sufficient. But basically just put in debug. Just put in debug. Always put it in. Related macros. Okay, so then there's all of these. It's like format, write, print line, print, tons of these. So write. This and write line are two macros which are used to emit the format string to a specified stream. Yeah, so this is what we use in like the debug itself. Like when we're manually writing it. So you write it to a stream. Print, this and print line emit their output to standard out. Similarly to write macro, the goal of these macros is to avoid intermediate allocations when printing output. So what's the difference between print and print line? Because that doesn't really go into it here. Oh, look at that. I have a new line character add. So print just prints it out. So let's like not worry about that again. We don't really need you. We don't need you. Let's bring in this this for loop again. Let's say if we don't use print line like this, it's just gonna put them all on one line. Or not. Let's take this out. Let's try to, oh, no, don't do that. Let's just do a simple print and spaces. So we're just gonna do that, comma space. There it goes. So it's all on one line like this, and print line gives us a new, well, line, which makes a lot of sense. So if I wanted to make some kind of like loader for a command line, I can just use print for that and like have it overwrite. There's actually a reason to do that. If I wanted to do something where it's like that, what is it? That. Let's see. I think I can do like a let here, like loading. Equal to, let's just create an array. Oh, look at that. Okay. So that's like pretty close together. I kind of like that, except I don't also, I want you to be characters. So I want you like that. Sure, there you go. And let's just do one of these. So starting over with that. Why are you upset? Oh yeah, I do need to do that. Never mind. I need to escape that because that's the escape character. Oops. Okay, so I need to iterate through these. So I want for loading hair in loading characters. If I just do this itself, I get the character each at a time. Now these are not copies, so I should probably do a dot iter. So I get a reference to it instead. And then I want to print this loading character. Now if I run this, I think it's gonna print them all out one after the other. Oh, come on. Like that. Now, if I want this to like go back to the beginning again, is there something in print? Oh, that's the same thing. To have it like go to the beginning of the line. I don't know. If there is anything like that. So tons of these. I kind of don't want to go onto all of this stuff right now. Yeah, always use right, basically. I don't have anything in here to like then say, oh, go to the beginning of the line. So that's too bad. I was kind of hoping that there was like something in here where I can say, hey, now go back to the beginning of the line and then rewrite that as part of print. And maybe there is, oh wait, I think it's like /r, \r. I think I can do something like return, but no new line. So it ends right here. What I really want to do is instead of this for loop that just goes through it once, let's do a just while true. We'll have to have like our index. So let's, yeah, mute index equals 0. Our loading character of index. We'll then have to do a index, sure, that, which then should set it to be what I want this to be. And then it's gonna print the thing out forever. This should be pretty fast. Oh, cannot find value loading care. Oh, loading cares. Oh, and this could just be replaced with, instead of a while true, a loop. And if I run you, that's probably a little bit too fast. I think we can do a sleep on this. So if we do the timer, no, it's it's something in threads. Where are you? I forget where like sleep is. Oh, don't do that. Is it in time? No, I think it is in threads. So I think it's like thread sleep. And then we'll get into that later. But if I want to slow down, here it is, thread sleep. So public function sleep. So standard thread sleep is what I want to do for this. And then it takes a duration. So if I want to do like sleep, thread, so use that, sleep, and then I need to give it a duration. So we're going to use a duration from milliseconds. Let's give it like 250 milliseconds. And then if we run you, are you not running, or didn't like that? Is that because this terminal doesn't like it? Let me try a real terminal for this. Oh, and so we're going to do a cargo run example, and this is FMT. Oh, I was kind of hoping that this would work, that it would sleep for 250 milliseconds, but it looks like it's just frozen forever, which is not exactly what I wanted. I wanted it to sleep for 250 milliseconds. So like print this thing, bring it back to the beginning. Maybe I really want to do something like this. But it's not really showing. Maybe that R is not working the way you want it to. I take you out. Okay, yeah, the sleep is just making it not display whatsoever, which is unfortunate. That's kind of not what I wanted. Put the current thread to sleep. Function is blocking. Oh, wait, currently specifying a 0 duration union. Whereas in Windows platforms, the interflying sleep skull is always invoked. If the intention to yield the current time slice. Oh, okay. So yeah, I don't think this is doing what I'm expecting it to do. I wanted it to loop forever and then print out something like this. Oh, wait, am I incrementing I ever? I don't think I was. I don't know if that would matter. Something like that. Oh, I plus 1. Never mind. That is incrementing I too. We're taking I plus 1 and then doing that. So it should go up to 4 and then back down again. We could like print line. Just to sort of see what we're getting with this I. Just to make sure it's not something silly here. Oh, yeah, it is very silly. Look at that. 1, -2, 3, 0, 1, -2. That's not what we want. However, now we're getting all those things. But yeah, that's not correct. So I is that. Loading characters of I. So we're starting with 0. Yeah, that seems strange. And then if I'm trying to do the \R now. Oh yeah, that's just killing. Oh, that's just overwriting it with these. Yeah, I'm kind of surprised that this isn't working. At least because like we're getting this print line. Wait, no, I want that one. Want to stop that one. But we don't get anything, which is too bad. I guess it's like printing out and deleting it instantaneously. A little bit strange. We'll have to come back to that later on and play around with it. ePrint is used to print to standard out, which is or standard error, which is nice because then if you want like logs for standard error to go one place and your out to go to a completely different place, this is how you do it. Oh, maybe it's something with flushing and standard out. I constantly forget that. You're probably right. I think you're right, and I don't know. Standard IO write flush this output stream. Oh yeah. Okay, so I think we need to write this. That's just a function on flush. Is there? It's IO write. Slash flush, file flush, buff writer, line writer. Like there's this cursor flush, standard out flush this output stream, but I don't know how to flush on like a right line. Like a print line. So if we do print so here's this macro print is, oh, note that standard out is frequently line buffered by default, so it may be necessary to use IO standard out flush to ensure the output is emitted immediately. Okay, so this is what we need to do, is this flush. So that's in this standard IO write. Okay, so thank you for that, Maddie GOG. We want to come into here after our print. We want to then immediately display this. So that's going to be this entire standard IO write. So write. Flush. Flush just takes in itself, so we don't need to do anything. And then we'll unwrap you. You. Oh, it takes one argument. Okay. Oh, because it needs. Takes in self. So I can't actually use that here? Oh, I need like this. I need to create a buffer for it. Oh, so this is different. Oh, standard IO standard out. Okay, so that's a different one than right. Let's try that. So we can do IO standard out flush and wrap. That seems to work. And if we run you, there we go. Take a look at this. Here's our little loader that we can show up wherever we want. And it just like does a nice little rotation around. So we can get a terminal little loader for this, which is nice. So if you ever want to like build something in your terminal where like just, you know, shows that it's doing something, this is a way to do that. Thank you, Maddie GOG. So I want to sort of go back to arrays. Because like as we've been going through this, it's like, oh man, if we just keep on like diving into everything, we're gonna get so lost in what we're supposed to be doing. So I kind of want to like reset our plans for this. So we have come on. Oh, fine. We need oh, come on. You get deleted. Okay, we're currently at arrays for this. So if we go into there, I also want to sort of feel that we're currently at this, and maybe we are like next up essentially. So toggle, maybe like we can have a queue, and we'll just like manually drop these into the queue of like what we're going to look at. So if we come back to arrays, we have this like format debug. And then there's going to be this like into iterator, which specifically is standard iter into iterator. So yeah, into iterator for a trait. Right, okay, so I'll just copy all of these out once we get to them. Back. Okay, so partial equal. And these are all traits. So I'm just gonna bring this over to the left, over to the right. So that is partial equal. So traits, partial order. Equal. And ord. I guess then there's hash. As ref. as mute. And so what's really interesting about this is like, you can't do this with vectors. You can only do this with arrays, which is like just run the trait on here and it just runs everything on the children trait, like on everything inside, which is really nice. Borrow and borrow mute makes sense too, because you can't borrow the entire array without borrowing everything inside of the array. Borrow mute. Okay, so I'm going to take all of these essentially, and we're going to throw them into our queue. And then we'll just start from top to bottom, and like we've already gone through like some of these, but we'll just like make sure we re-go back through them if necessary. Okay, so we already talked about default. Raise cores the slices t to a slice method, may be called on an array. Slices have a dynamic size and do not coerce to arrays. So slices and okay, so primitives are slices. That's interesting. So back to arrays. Is this different since last time? So arrays coerce to slices, but slices cannot coerce to arrays. So arrays can coerce to a slice. And really that's just like slice like that. Now your slice, primitive slice, which, oh, you're not even shown in here. Ooh. Hold on. Under primitives, we need to create a, oh no, here it is, slice right there. Why do you not find it? Let's see it in functions, traits, structs. All right, let's name it something different. Name you primitive slice. There you are. Okay, so arrays can coerce to a primitive slice. Which does mean that this primitive slice is going to be coming up in our queue too. But we can't go back the other way around. So that's because like the slices are dynamic size, meaning that we don't know what the size is, but I don't think we can change the slice. I think it's just like the compiler just understands it doesn't know what the size is going to be. You can move elements out of an array with a slice pattern. So that's where this entire pattern thing comes in, where we can use like the dot dot stuff to get stuff out. Okay, so then we go through all of these. Okay, so then we talked about into iterators. Implementations. This is the new thing. New in 1.55. Map has been removed from nightly only into just normal methods and is completely available to us. So we can actually take a look at it now. So we have this map. It's going to take a function. Where f is a fn mute. And it's going to return a u of something. And n, which is I think the same size of the array. So it has to return a same size as the same array. Is it the same? Is it the normal map method? Returns an array of the same size itself with function apply it to each element anywhere. So it's a standard map that you would see it like applied to any other thing. So like the same vector like iterator map, same thing here. It sounds like. So yeah, we can do this. We're like v+1. So basically we can do this on normal arrays, which also means array slices. Like we haven't looked at slices yet, but let's head back into arrays. So here I have these names. And let's say that I wanted to change these all to strings as opposed to just like maybe I want to change the strings and like add like an exclamation point at the end of them. So like let names with bang equals, so we're gonna say names names dot map. I don't think that works in Rust. So we can take in the name. And so if I want to do something here, we have to like, I think do a format. Format. And bang name. And then at this point in time, we can just print out these names with bangs, which will give us what we want, which I don't think I have to do that. Here's our, oh, apparently we do. String doesn't implement center display. Okay, never mind. We do have to do debug format. So if I run you, where are you? Here it is. Oh, because we're doing the entire array itself. Like we're printing out the entire array. And I think we can do hash to make it pretty print. And here it is. We now see that we've mapped through this array and mutated each one. Now we didn't actually mutate the ones in place, right? Because the original names are still here. They're exactly the same thing that we left them on. Map doesn't mutate. Instead, it is giving us a and read only. I believe that this is read only. So we can see those as strings because I don't think I can do something to this. Let's try. I'm gonna move all these things into a different function. So like function, like play with maps. Arrays. And I want to move all of you down into here. So now here we can just do play with arrays. Or not. And this way I don't have to do this bang like that. Let's do another function here. Function array maps. And we can call this. Okay, so given this, like the way that maps work, if you're not familiar with JavaScript, which is like most people learn map through like something like JavaScript. I think Python also has one, and like almost all functional languages have them. It's a very, very interesting and fascinating and super useful method that you find on like array or list types on these different languages that implement functional type things. So a map allows us to basically just go through every item. So here we're gonna have this like array with 5 things. I can go through every single item and I want to change it in some way. And it can be like a vastly different way that we change it to. I can even change them into structs that wrap around the original items. If I so wanted to, I could add something to it, which is usually what the example that you see in JavaScript. Oftentimes I'm taking some like value from a database call and I'm changing it into like a format that's like best for displaying to the DOM. That could be something you do in JavaScript. In Rust here, you can do very similar things. Like if you have something that wants to like display it to the screen, but it needs it in a very specific format, you're just getting the raw data. You're mapping through the data set that you got and changing it around. That's exactly what we're gonna do here. So if I wanted, like the classic example here is the add one. So we're gonna do and it always creates a new array. It never changes the original one. So we're gonna do let mute a with 1, a plus 1. Is gonna be equal to a dot map. We take in this number, whatever it is, and this closure syntax, and we're going to return that plus 1. And so now if I do this debug of a plus 1, we should see basically 2, 3, 4, 5, 6. So let's run you. There it is. So pretty standard stuff. Pretty like it's it might take you a while to sort of like get used to it if you've never used it before. Once you get used to it and you start seeing all the places you can use it, it just becomes magic. And you just, it untangles a lot of like manual loops that you might have to do yourself. On top of it, what is this returning? Like, you're returning an array, aren't you? It's actually an array. So previously in like vectors, it returns like a map, like a vector map or whatever it's called, which is interesting. Yeah, you return a true new array, meaning that you can do multiple maps on top of it, which is nice. So like I can return everything on here, and then we can just immediately do another map for, some reason. Maybe we want to like then in here multiply by 2, for example, is what Copilot is suggesting for us. You don't need to be. We'll call this like changed A. A does not need to be mutable. I'm not changing it whatsoever. And so now we can see it's got +1 and then multiplied off. So we can call map like multiple times, one right after the other, because they're actually just arrays that we're getting back, which is really nice. Now, some people are will see like a map and think like, okay, this is iterating through in a really sort of nice way, and I can then do side effects outside of it, which is unfortunately possible to do. You can totally do whatever you want. We can throw in let's do like another map on tape here. What if I take in like my number and then I just do like a print line with that num, like I can do that. It's and I don't need that, right? The problem, like, this is totally legal, but notice, what am I going to return here? So let's take a look at change day again. What does print line return? Let's find out. Nothing. It returns nothing. So change day doesn't have what we expect to be in there, because whatever is returned from that that map becomes the value, like that position at value inside of like the resulting array. So even if you're like feel like you can just use a map as like a normal iterator to go over and like do stuff on, don't do that. It's too easy to like make mistakes like this, and then suddenly you don't actually have what you expect to be in here. So it just don't do this. If I were to like return something else, then like maybe we'd like return 5. I think I would need to like, oh, I think I need to like do a something like that, and then everything will become a 5 at this point in time, even though my print line is like the previous thing before it. Anyways, it's just not a good practice to like do side effects inside of a map. There's better ways to do that. And for those better ways, I would do something like a iter like this, and then you can just do like a for loop over it, and or maybe we can even just do like a for each. Yeah, for each. And that's when you would do your print line. That's a much better way of doing that, because for each doesn't change what we'd be expecting to get out here. However, in this case, for each won't return the map, so then we'd still be out of luck. Okay. So that is map now available on arrays, which is really cool. I like this a lot. And that was like the big difference. All these other things are nightly only, so we're not going to look at them. Okay, and then we have our trait implementations, like what we can expect to see and like run off of arrays. So traits, we have this as mute. Oh yeah, as mute, like that. As mute. There's this as ref. Borrow again. Borrow mute. Debug, which is nice for being able to print them out. And then default. Now, this default is interesting because it's clearly made from a macro, because we can see, okay, default for type an array of length of 16, an array of length of 27, 24, 6, 0. It is actually quite interesting what, like, also that it's in this order. Like, I don't actually know how it possibly chose this order to do. Hash is also another trait directly on implemented for arrays. Interesting that this one has documentation applied for it. The hash of an array is the same as that of the corresponding slice as required by the borrow implementation. Okay. Okay, so then impl index. Okay, so then index is also another one. Index mute. Into iterator, we've used those plenty. And then, so then here it's interesting. Okay, there's these two into iterators. So what's the difference here? So we have impl t const n, which is the size into iterator, and then over here is impl lifetime a type t const n into iterator. Oh, look at this. So into iterator for like owning, like taking ownership, or I guess copying, or for a reference. So both of those are things. And then also a mutable reference for that too. Okay, into, so ord. Partial equal. Partial equal is really important because we use that for like, hey, is this array like kind of the same as this other thing here? Which is, it's nice that you can do that to entire arrays. And we see, okay, so two partial equals again. Here's like a reference, here's a mutable reference for that. And then here's just ownership for it. But it's the same, it's like re-implemented multiple times for that. Now, what's this difference? Like there's partial equal implemented for ownership twice. B, and then a number, and go back. I went to the top accident. So partial equal, so B, okay, so BN for this one, and then just B for this one. But they both take in AB. This one is for a slice, or is it for just the entire array? And this one is for a slice. Interesting. What's the difference between them? Partial equals Bn, where A partial equal B, whereas here partial equal B, where A. Okay, so that's the same. Function equal other. So like other is B of n of length, and this is the slice of B. So this one, it has to be like a very specific length that it's checking. Whereas this one, it's not. Then Boolean. We also notice that it's a string slice, so it can be dynamically sized. So this is perfectly fine. And then self is equal to other, whereas here, this is spec array equals spec equals self other. So it's calling a method to do that for us. That's interesting. So we'll probably be getting into that a little bit more when we get into partial equal. All right, so there's this partial ord. Okay. Slice pattern, but slice pattern. So slice pattern is on here, but it looks like there's a bunch of the only two things that are on here are actually nightly only. So I'm let's see. Nightly. Nightly. So this is going to be that slice pattern. Oh, which you don't know of. So let's go find you. In this is in traits. Slice pattern is in core slice. Oh, it's a core thing. Oh, and we're not looking through core right now. We're just looking through standard. So that's actually really interesting. That's why we can't find it. Try from is from string. It is definitely from standard. So we're not going to see that. So this is try from. I don't see this as a trait in here. I see them in structs. So let's go. Traits. This is, yeah, just standard try from. Maybe, oh, convert. Oh, here it is. Convert try from. That's what it is. So convert try from. Why can't I find you? Hold on. Let's go find where this in again. So traits. Yeah, convert try from right here. I want to just copy you. Okay. What? No, don't do whatever that is. Okay, so we have a couple different try-froms. We have like a reference with anything, a reference with a specific lifetime. So like a, I guess, auto lifetime. A very generic lifetime. So both references. Mutable reference, and then try from the actual full thing. So that's nice. Then we're going to the auto traits. So auto traits are interesting. Auto traits are things that are like automatically applied to stuff. So that can even include our own unique things that we create. We just sometimes get auto traits added to them. So we have this ref unwind safe. Which is off of panic. And then we have this send. Send and sync are part of this markers. I think it's like the marker by marker sync. There it is. And then unpin. Now I haven't played with unpin at all. I heard that it's something to do with async code is where unpin really comes in. But we'll obviously be getting into that. Wait, try from, did you not take? Hold on. Just link to page. There we go. We have our unpin and unwind safe. So before I forget, we have these traits. Let's just add these to our list in the queue. Oh, I put it there. I didn't want to put it there. Okay, so each of those, and then we have our auto traits. And we'll put those in there too. Okay, and then there's these blanket implementations. That's just like pretty much everything get these regardless. So the any trait, which we went into in that like course that we did on the last ECS implementation, any trait is super interesting. Basically everything gets any trait, and it allows for like really fascinating dynamic dispatch. Borrow. So we can borrow anything, really. Now, what's interesting is that these are blanket added on, but I guess like it's borrow T for T. So that's specifically like borrow for the full array, whereas these other borrows are more manually implemented for more control, but we can still just do the normal borrow on it. The from trait. From and into. Oh, there's two. Oh, convert into. There you go. And then to owned. Oh, it doesn't know what that is. Are you core? No, you're standard borrow trait to owned. Okay, so you're off of borrow. Borrow to owned. Can I find you in here? To owned? No. Oh, that's like searching just this page. I want to search like to owned. Okay, so this borrow to owned, that's what we want here. Borrow to owned. Borrow to owned. Oh, come on. Try from. There's a, it's not exactly try from. Let's see. You're from convert try from. So we have try into there. Can I do, what do I need to do for this search? control P. This is try from. Yeah, convert try from. If I want to get the link, that is control L. Hold on. Do that, link. Okay. This try into, which I think we saw it trying to give us. So that's the try into. Or not. Can you not find it? Oh, there it is. Let's see. And that's it. That's all of the blanket traits that are added into. So let's go ahead and copy you, and we'll add these in to our queue as well. So now tons of things for us to look into. Everything specifically from arrays. So there you go. You're done with this. We can now start playing around with the rest of these. So if we're gonna move you up into here. Now we looked at copy before, and I don't think anything sort of got added in, but this is just this marker trait. What are you? You're a marker copy. Standard marker copy. And yeah, we went all throughout all of this. Is there anything else we want to add in here? So we have our notes. For marker, it's basically for copy specifically, there's no methods associated with it whatsoever when you apply it, but it has to be applied to something that implements clone. Went through all of these. Implementations on foreign types, like there's tons. Implementors to look at like who's implemented it, which is like a lot of things. And that's it. So yeah, I think we're done with this one. We don't have to worry about it. So you're done. Clone, we also looked into. There might be more to look into it for it. This is really just clone. So standard clone. Basically, we can implement our own version of clone for this. Something we did find out is that if you're trying to do the copy is not going to use the custom clone version. Copy is actually faster than clone, or it can be faster than clone, especially if we do our own clone. So I thought that was interesting that we found. Okay, so required methods. So here we see like clone itself. We have that here. Provided methods. So these are the clones that are given to us. We took a look at clone from. Then we have these implementations on forends and then the implementors. I don't think there's anything else. I think you're just tons of things implement clone. Okay, so we're good here. Done with clone. Debug. Let's go take a look at debug. This is format debug, which allows us to do that question mark formatting. Oh, and this is where that module level documentation is. We took a look at that earlier today, which is really fascinating. This trait can be used with the derive of all fields implement debug. And it suggests, hey, just use the derive with debug, but can only derive debug if all fields implement debug. Which is the reason why if you're writing a library or anything like that, just implement debug on everything is kind of the best practice. And then you can use the hash to pre-print it, which we saw in the module level documentation here. Derived debug formats are not stable, and so may change with future Rust versions. Additionally, debug implementations of types provided by the standard library are not stable and may also change with future Rust versions. That's interesting. Deriving and implementation. Okay, so it's just that like derive is how to derive. So it's like pretty simple stuff. Well, like I think most of us have done this before. It's like one of the first things you really learn is like how to do this derive debug so you can take a look at what the heck is going on. Now, manually implementing debug is a little bit more convoluted. So let's go ahead and throw this in here. So we don't have a debug. Let's add you in. So if I wanted to manually implement something, so let's do like a struct location, and let's say for some reason our location is really just like a point. Well, let's do this. We'll have our X and our Y. That's the I32s. And for some reason, I don't want to derive the I32. Let's do it once really quickly and we'll see what that ends up looking like. So we'll do location with debug. Yep. So we can do let point. So point with debug. And then we're going to debug this out. Point with debug. If I run this, then we'll just see, hey, here's our X1. Perfect. Now, let's say we have a location that we don't want to have debug on there. Struct location without debug. And then I want to debug that one. This is no longer going to work because I can't do debug. Debug is essentially just like the print line, but with the colon question mark on it for like the debug printing. However, you can't actually do this without debug implemented it. So let's go ahead and implement this ourselves now. So impl debug. So we're going to have to use this standard format debug for location without debug. And then for this, I'm going to go ahead and implement the missing members because it's always, especially for a debug here, it's really much nicer to use something like, oh, that's maybe too much. Something like Rust Analyzer to help us out because this is kind of a mess. So as we can see here, we're going to get this F, which is a formatter. And we need to use this as part of like a stream to like write out to it. So we can see that here's the standard result. We can actually see here that it's kind of like Rust Analyzer is kind of written this for us. So we can do this F debug struct, give it the name of what it's going to be printed out. So it can just be this like location without debug. We can just say like whatever. It's whatever we feel like. And then okay, so field. So our field here is X and Y, and then we can just give it what these are. That being said, I can totally mess with this. I can say like field X, I can just skip it. We can just say, hey, the only thing we want to show is like X. And maybe we want to be just screwy and just, you know, say that there's going to be the Y here. For some whatever reason. This works now. So I can now run our code. And we now see X is 2 when we know that it's the Y value that's the 2. So because we've overwritten debug, it's kind of up to us to do it correctly, and we've purposely done it incorrectly here. So let's go ahead and redo it in a good way. So we're gonna say that this is what X. Now we can change what this looks like. So we can just say like, well, it's like field X, and it's going to be displayed some other way later. Let's do another field. So the name of this field is going to be, let's say like Y here. And our value is just a reference to self.y. So that's it. And then I want to change this to back location without debug. Let's run this again. And now we see location without debug here. And we see the proper information that we want. Coding Garden fan, hello. So it's good to know to be able to do this, but again, best practice is to not implement this yourself unless you absolutely have to. And this is like, if for some reason one of these fields don't implement debug for you, then you probably have to do this and like maybe just do something like value, you know, this is a Y. Oh, and it needs to be known. Let's do her. I don't think I can do that. Oh, I can do that. So if I run you, then yeah, like, yeah, we don't know what this is. Like it's something else. Again, don't do that unless you absolutely have to. Lazy programming tips. Exactly. Lazy programming, it turns out, is really good. Just do the derive. Don't have to do all this work. Like just be lazy. And it works out clearly. Okay, so this is manually implementing. Or we can do that. Oh, yeah, let me. It's more like this. Down here. Okay. There are a number of helper methods on the formatter struct to help you with manual implementations, such as the debug struct. Debug implementations using either derive or the debug builder API and formatters, or yeah, so we can do all sorts of like pretty printing type stuff if we really want to. With like that kind of stuff, which we already looked into. Okay, required methods. So the format to actually like format it, which we saw here. So we have this MT. So basically like you run this to actually like, you know, set up, I guess tell the compiler what to display, or how to like what display when formatting the object for debug mode. Implementations on foreign types, and then implementors, and I think that's the end. Yeah, there's nothing else here. Can I just like close off those sections? I don't think I checked. I bet I can. That would be so much easier than scrolling. No, I can't. Okay. Never mind. All right. That's this debug. Done with you. All right. Now we're going into some empty stuff that we haven't looked at yet. Into iterator. And this is iter into iterator. So we're doing standard for this. Okay, so conversion into an iterator. By implementing iterator for a type, you define how it will be converted into an iterator. This is common for types which describe a collection of some kind, but we might be able to do it with something else. So the benefit of doing this is that we can now work with for loops, which is actually pretty nice. So tells the compiler how to iterate over the thing, the object, which allows for use with for loops. Now, something that we can do with this is we can make something like that struct, or maybe an enum that that can work with for loops. Let's do it with like that location struct. So we're going to do into iterator. So we're going to do a struct location. We have our X and our Y. I know it's going to feel like a little bit weird doing this, but let's imagine that I want to be able to just loop through location for some reason. So I want to do something like for something, yeah, sure, loc in location. I think you can do a .iter on it then, or maybe I can just do that, and then we're gonna just print line what this location is. Sure, we're gonna do that, but location doesn't implement. It doesn't know how to deal with this. Oh, we need to create the location. So let location is gonna be equal to, there you go. Let's do like 0 and 1. Now it's saying, hey, this doesn't implement into iterator. Well, let's do that. So impl into iterator for location. Let's implement the missing members. Okay, so type item. Like, what is the item gonna be? I also see, like, where is item used here? I don't see that being used. Let's go take a look at the documentation and see how it's supposed to be used. Type item. Let's see. By implementing iterator for a type. Okay. I don't see that there. Okay, so item is going to be this I32, which we see is like each element inside of here. So that's going to be the specific element being passed over into the for loop. So we know that these are all I32s. So item is going to be equal to an I32. Okay, so we have this type into iter, which we see here, standard vec into iter self item. Now this is for like, oh, that's like an entire vector in here already. I don't know how I'm gonna do how we do enter iter. Maybe it'll tell us what we need to do for it. But then here, okay, so function iterator, return that to self.0.into iterator, which that's not helpful for ours, because if I want to be able to do, like turn it into an iterator, like I think we need to set you. Oh, okay. So if we do like an array, can I do an array? So iter. So standard vec into iterator. Okay, so they're using the iter into iterator from a vector. So can I do this from an array? It's like standard array into iterator. Let's do that with I32. So we're gonna say, hey, it's gonna be an I32. Selective duplicate, hello. Maybe iterator first for type, and then it can be into iterator. I think like we're sort of like stealing from the arrays then, right? And then for this into iterator, where we're gonna turn this from, we're then gonna say, okay, we're gonna do, yeah, pretty much this, the array with self.x and self.y in it, and then into iterator. That's what we're doing. So the shenanigans we're getting into right now is like looking into manually implementing into iterator on your type that doesn't normally be able to do that. Okay, you're upset. Struct takes two generic arguments, but one will, was it the size? And the number. Okay, so the number is 2. Expected struct 2 usize found struct slice iterator I32. Oh, that's not. You don't like that. So this should be owner. This is like copied over, so it's owned. This is like owned essentially, and then into iterator, but it doesn't like it because the mismatched types. Okay, so expected struct. Now, can I just say this? Can I actually just tell you, hey, I don't care. No, placeholders are not allowed here. So we have to say you're an I32 because of this I32 here. You are upset because even though I32 to usize found struct, you learn to implement iterator for a custom mathematical sequence, specifically the Icanobif sequence. I have never heard the Icanobif sequence. What is that? Oh, it's similar to Fibonacci sequence, but the two previous terms are reversed before being added. The sequence is thus attained in this way: 1, 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8. Wait. Oh, the first Icanobif. Oh, Fibonacci backwards. Ah, okay, cool. 1, 1, 2, 3, 5, 8. Wait. Oh, because you're taking this and reversing it. Oh, okay. That. Oh, that's fascinating. That's gonna grow really fast. That's interesting. I've never heard of that. Okay, so you need to be, oh, look at that. Self item. I wonder if I need to do, no, because that's, oh, self item. So can I just say self item? No, because you need to be, so structure defined with two generic parameters, type and n. So this other one needs to be the n, which is size 2. Now you are upset because expected struct centered array into iterator I32, which is fine because that's what we got here. But why is it found struct? Oh, slice iterator. Array into iterator provides there's a whole database of that kind of stuff. Oh, crazy challenges then. Cool. Interesting. I usually sort of like have fun with them for a little bit of time, but then get bored after not too long. But like it's probably something I probably should do. So what type are you? You are a slice. So do I have to actually say that you are a slice? So standard slice into iterator. Missing lifetime specifier. See, I don't want to have to do that. I don't want to have to do like that kind of thing. Because then I have to do lifetimes up here. So I really want to have this be the I don't think I can do that. That feels, yeah, I cannot find it in this scope. Let's see. So if we do standard array, hold on, into iterator, and then we have our type. So that's a self item, and then we have, oh wait, is it just usize? No, yeah, usize. Is that what you need? No, you need to be. Oh, a const n usize. That's okay. So it's a const n usize. Can I say like const location size, which is the usize equals 2. Let's just move you up to the top. And you are going to be this location size. Are you happy with that? Sort of, but then we run into this problem again. So it's this, so we have this array here. And if I do like iter, like that, Can I do into iter but not return, just return to function? No, I need to call the print. I need to call it. But when I do that, then you're upset because it expected an array into iterator, but it found a slice iterator. Fish 13001, hello. So that's not right. Now we can go take a look at array again. Let's go take a look at arrays into iterator. So into iterator. So actually we see there's a couple different implementations of it, which is, yeah, there's that one. And I think we want this one. Now, how do we make sure that we're getting that one? We can turn the array into a vector and then get the iterator, but that feels not right. Oh, this is like the reference. And I want this one for T and N. So this is the one we're using. So this is standard iter into iterator. Can I just say that it's standard iter into iterator? Standard iter iterator. Can I do that? Which I am. Size for values of type dyn item equals cannot be known as compilation type. Okay, so hold on. Self item. Oh, into iterator. Yeah, that's probably right. Treat objects with dyn are deprecated. Why do you need dyn? Oh, this trait takes 0 generic arguments, but 1. Okay, never mind. I'm not supposed to supply that. Okay. So I don't. These implement copy and clone, so that should be fine. So that's literally the documentation we were looking at with how to do this. But like, okay, so we want to implement this essentially. Now they're cheating. They're using a vector, which already has iterators in it. Existential question. Yes, I did that this morning. I updated to Rust 1.55 so we can use maps on arrays. So that gives us like this into iterator, but oh, trait bounds, but like that's not helpful. Oh, it's not a cargo command. That's, I think that's where it gets like a little bit interesting. So it's a rust up command. So rust up show will show that I have stable Rust 155 installed. So this into iterator, type into iterator. Okay, then we're returning this self into iterator. And I could control what that is. So, well, hold on. Okay, so what the heck are you? So like let a equals that. You're just this iter. Go to iter. Like what type of iter are you? You are a slice iter. So can I just say that I want you to be a standard slice iter? Now you take one generic argument. So you're going to be a self item. Missing lifetime specifier. Okay, so can I say that? No, I have to do a named lifetime. Okay, so let's do a named lifetime, but now we're gonna say, hey, this is an undeclared name. So now I have to do like that. And it's not constrained by the impl type, right? Let's see, where do I put the rest of them? Did I put you in here? Oh no, I have to constrain it. Like with where. PMS, hello. Inter-iterator is a trait, not a struct. That's why it's complaining about dyn. Oh, I have to give it a struct. Is that why? From Stack Overflow, let array equals that array iter, standard array into iterator, new array. Oh, standard array into iterator, new array? Wait a second. The standard array new, and then the array would then just be this. Self.x, self.y. And so if we return u, we go back to what we were trying to do this entire time with the array into iterator i32 standard array. There we go. Okay, thank you, Fish, for finding that. So we want to use this iterator, which is a struct. So, and then schemas, you are correct that we need to return a struct out of here. So this type must be a struct. A struct. And this is going to be the type of the things that we're like actually returning out. So now this should work. We should now be able to run this and see the 0 and 1 in our very, very silly for loop through our location, which should never actually have a for loop defined through it, but it works. Dyn into iterator would be a trait object that might have worked. We could try that. So we do this type into iterator equals dyn into iterator. Now you take Value substitute types. Is it one type? Item equals types into iterator equals type. We need both. Need both. Okay, so we need so item is A32, but we still need the value associated item must be specified. So into iterator still needs to be a type. So unfortunately, we still need to then do this entire thing, I think, inside of here. So then that's gonna be into it. Oh, come on. It's into iterator equals probably you. Oh, it's not an iterator. Oh, you need to be an iterator. Interesting. Okay. I can't remember how we were getting the original Dyn working. Like it was something like standard array into iterator, doing something like that. And then for you, doing that, and then make you Dyn. Yeah, okay, so it doesn't like this. Expected a trait, found a struct. So and I guess into iterator is a struct. Yeah, that's what you are. Hold on. Standard array. I guess it would need to be that iterator, but then we run into like the other fun thing. So I'm not going to go down too far into that rabbit hole. Nope, don't do that. We're just going to keep this one with all of its fun glory, but that is how we can implement into iterator ourselves. So that. Okay. Let's see. Selective duplicate. You still feel tempted to move to VS Code from Vim, just for how easier and seamless it is to use the toolings for Rust. Like what though? Because there are toolings for Rust in Vim. Are you using NVim, like NeoVim? Like I know a lot of people are using that. And they say that they like it. I've been considering like trying out Vim for Rust. Just to sort of feel it out, see where it's at. Yeah, NeoVim. I mean, I've heard it's good with it, but I've never done it. So either way, I've been using VS Code for it. Okay, so iterator for this, then we can do that. It's common to use into iterator as a trait bound. So like, hey, I only want this thing if it can do an iterator, then you can do stuff like, you know, collect and into iterator. Gray Jack, for you use VS Code for Rust because you're really into the semantic highlighting. Yeah, it's that is nice. Yeah, the highlighting is nice. Okay, associated types. So we have this type item, the type of the elements being iterated over. So we'd already seen that here. So type is the type of the items being iterated over. We can only have one type here. Then this into iter. So which kind of iterator are we turning this into? Okay, so we have this required methods. That's going to be this like into iter. That's going to be basically like creates an iterator from the value. Okay, so creates the iterator like from like self, right? So from self. Now there's this module level documentation for iter, but not going to worry about that too much. Although module standard, let's go add that in. Modules. Module standard iter. And then that gives us the ability to do like next on it and all that fun stuff. You're just so impatient and manual configuring all the stuff. You have a good config now, though it works. You place VS Code in a better position for what you get out of the box. Yes, I would agree. But there's also like a lot of things you have to install, and I have to constantly like restart Rust Analyzer because sometimes it just fails. Into iter moves the values. Yes, it moves or copies the values out. Yeah. Although, hold on. Yeah, look at this. So into iterator, we take ownership of self here. That's something that's really important. Now, I bet if I implemented like Conan copy on here, then like maybe it copies into self, and then it doesn't matter as much. But like that is a good thing to note. So we are taking ownership of self here. Okay, then there's the implementers, and we just know that we're done with this then. Now, does that give us iter for free? Like, can I do location.iter now? No, so it doesn't automatically now add iter to my stuff. It's just into iterator is now on there. You can implement into iterator for reference. Yes, absolutely. So we can do impl iterator. I think it's for like that. Is that how it works? And then you're going to be a reference to that, and then reference. No, it's not there. Where do I put it? Oh yeah, in the implementations we can see it there. So we can see, impl for, that's it. That's how I do it. So like for a reference to location, type mismatch, resolving that. We need, let's see, static, expected I32. So then you become a reference here. But now we need a lifetime specifier. So then we need something like a lifetime there, a lifetime there. Okay, great, but now we need a declared lifetime. So then we have you, and then we need to constrain the lifetimes. Like, it becomes a little bit of a pain to deal with, but it is possible. Now this would be interesting. What if I were to say this, like, hey, I want that, and I just want you to be full. You're going to be this self item, and you're full owned. Can I do something like this? Because it copies over just fine. So yeah, this works too, where I'm like, hey, it's like, I'm okay with copying these things out because they implement copy. So therefore I'm okay with that. So then this works. Now I'm going to take you. No, you're still not happy with this. Okay, I need to change more. Oh, it's like function reference. I kind of want to, okay, hold on. Let's try this again here. So impl into iterator for a reference to location and implement missing members. Okay, so you still take ownership of self here. I guess like at this point, can I just debug location again? Derive, debug. Yes, I can. So that works. So I don't take ownership of it. And I can use location again. Even though I don't have copy and clone on location itself, the things inside of it do, so therefore I can totally do this. So that is nice to know. Okay, so that brings us back to here. We did into iterator. I'm starting to feel like feel my words aren't working quite as well as normally. So I think I'm gonna have to call it a day for now.